on design and analysis of smart patch wearable antenna for medical application. So this is our simulation HFSS software where we simulate all our results. At the beginning we create a ground plane and assign a copper material to it. Later we design 3D object for cotton substrate. The antenna consists of a hexagonal patch cotton substrate to offer wearable property and ground plane with transmission line feeding. Low radiation of 6 dB radiation decreases. Feeding is shielded from the antenna by a conducting plane with hole aperture to transmit energy to the antenna. Our project is used to detect early breast cancer using wearable antenna. We can now observe in the first case the cancer is not detected. Here in the model over the patch we can observe normal cell with no tumor, regulation and conduction. Written loss is minus 30.86 dB, gain of 4.62 dB with no cancer detection. Electric field response is stable for being if there is no cancerous tumor. The reduction in SAR value to preserve tumor, the value is as fixed by SAR. Now the next case is cancer detected. When the person with breast cancer or tumor after wearing, we will record the data with the tumor here as shown in the figure. Now we can observe the written loss is minus 27.6018 dB. Radiation or electromagnetic radiation enters tissue, it do not disperse in normal tissue, whereas there will be abnormal disperse in cancerous tissue, where we can observe the gain of 5.007 dB. We have observed the overall results, so we got the results of parametric simulation, hence it is clear for all cancer detected or not detected. This is the base model of 1x2 array. Now after completion of simulation work, come to the fabrication work as we have to compare our cotton substrate result with FR4 substrate. The fabricated antenna is tested in an anechoic chamber where the noise is very less. The process is going on as shown here. The process ongoing in anechoic chamber with proposed antenna to get optimum results of antenna. As we are comparing this FR4 substrate results to our cotton substrate result. Here the insert feeding technique is used, as in the wearable property cotton substrate is used and it is having transmission line feeding technique. With these results we came to know that FR4 is not having a wearable property. After this process we are in check with the wearable property of cotton substrate. It is having a wearable property and then we'll come to the conclusion. Now coming to next, it is a device called network analyzer which measures antenna parametric simulation. After the results of FR4 substrate, now coming to our wearable property cotton substrate, as we can observe in the figure that it is a material of cotton with thickness of 1.5 mm with length of 184.5 mm with width 168.75 mm and radius of 57.39 mm. As we can see the copper plate here to hold the property. By considering SAR, specific absorption rate. Now we have set to the limit to 1.6 watts per kilogram in 1 gram of tissue, considered good, healthy and can continue work by SAR through the Federal Communications Commission FCC. We can observe the written loss to minus 17 dB. This was the wearable antenna design model given for fabrication and testing work. We gave this model for fabrication and testing under two conditions, bending and folding, bending for 20 cm or maximum and folding under related, and we can watch gain as 6 dB. Now we finally compared our cotton substrate result with FR4 substrate result and we came to know that cotton holds good for wearable property. Now we concluded and shown all the results including fabrication and testing. Thank you.